Okay, today we are going to learn how to express a proper fraction like this into partial fraction. So how come it's a proper fraction? Because the degree of the numerator is strictly smaller than the degree of the denominator. Strictly smaller, cannot be same degree also. So this is a x squared, this is a x cubed. So the degree is 2, the degree is 3. It is smaller than the degree of the denominator, and therefore it is a proper fraction. So this is a proper fraction. So now, what does it mean when you have a proper fraction? You don't have to do a long division, basically. So now let's just look at the denominator. Then we have to look at these 3 scenarios. There are only 3 scenarios. So if it's a distinct linear like this, then we will split it into a over ax plus b plus b cx plus b, whereby a, b are constants. All right, constant means they are rational number. A, b are rational numbers. All right. So now repeated linear, I will split them as a over ax plus b plus b over ax plus b squared. All right, you must do it twice. It is possible that a or b can be 0 later. One of them may become 0, or they may become rational numbers. All right, finally, this one we can just split it into ax plus b over x squared plus c squared. Now, basically, it is a quadratic that cannot be factorized anymore. That's why it's called an irreducible quadratic factor. Okay, so this irreducible quadratic factor cannot be factorized anymore, and it always looks at in this form of x squared plus c squared. There is no x there, only x squared and only a c squared. Okay, so an example would be, of course, x squared plus 2 . Okay, that's one example. Okay, now, so which scenario are we looking at? Scenario 1, 2, or 3? Which one? Okay, we are looking at 1 and 3, right? So we have to combine 1 and 3. So the numerator will be a over 2x minus 3 plus bx plus c over x squared plus 1. I need to remove all the denominator. So I will multiply by 2x minus 3, x squared plus 1. Everything multiplied by the same denominator, 2x minus 3, x squared plus 1. What you do on the left, you also do on the right. Okay, if we cancel off the like terms, what is left is just the numerator in this form. Okay, so today I'm going to share with you 3 methods of solving this. 3 methods. The first method is very straightforward. You let x be a value such that some of the variable will disappear. So if we let x be 3 over 2 here, okay, then you will realize that this term will become 0. So this term will become 0, and you are just left with 8, 3 over 2 squared minus 11, 3 over 2 plus 5 equals to, so sub here 3 over 2. And once again, this whole term will become 0. That's the purpose why we chose 3 over 2. And we will have here 13 over 2 equals to a multiplied by 13 over 4, and a equals to 2. So this is method number 1. Let x be a value. You let x be equals to 0. Okay? So when you let x be equals to 0, because then I'll remove the b, right? I'm trying to remove some of the variables. I remove the b, I have the a, so I'm left with the c. So I let x be 0, seems like a good idea. So if I let x be 0, then on the left hand side I will have 5. On the right hand side I will have 1 times a. which is 1 times 2. And this term will become 0 plus C, 0 minus 3. I bring over, I have 3 equals to negative 3C and C equals to negative 1. Alright, so these two are the same method, right? I let X be a value in order to remove some of the variable. Now, another way of doing this is compare coefficients. Okay, I understand a lot of you will let X be something else now, right? Because you found A, you found C, you let X be anything you want and you can find B. Okay, but I'm going to show you another way. It's called compare coefficients. Okay, because we want to do the fastest way, right, and the smartest way, right? So let's compare coefficient of X squared. On the left hand side, what is the coefficient of X squared? 8. Now down here, this will give you the coefficient of X squared. So I will have A, and only this will give me the coefficient of X squared. So I will have plus 2B. So yes, you can do that. A is 2 and B is therefore equals to 8 minus 2 over 2. So B is 3. So we are done. Faster, right? Yeah, so compare coefficient is a very good method to speed up the process. And finally, please don't lose this one mark. 2 over 2x minus 3, and bear in mind there can only be one sign down here. So don't put plus minus. It's either plus or minus. So I put plus here. My B is 3. My C is negative 1. And I have x squared plus 1. So I did tell you there's another third method, right? Let's say I didn't use x equals to 0. Okay, I don't know that I have to use x equals to 0. So I will show you a method 3. I accidentally let x be equals to 1. And I also let x be equals to negative 1. Alright? So if I let x be 1, I found A already, right? This is what will happen. I found A already, but I let x be 1. So in this case here, I'll have 8 minus 11 plus 5. So left hand side is 2. So I let this be 1. So I will have 2A. 2A is 4, right? Again, I let x be 1. So I will have B plus C multiplied by negative 1. Because x is 1, right? So this will be negative 1. And what you get will be 2 equals to 4 minus B minus C. Alright? And therefore, B plus C equals to 2, equation 1. Okay, next, I will let x be negative 1. One more time, one last time. This is the last time. If I let it be negative 1, my left-hand side will be 24. Again, if I let x be negative 1, my left-hand side here will be 24. If I let this be negative 1, I will have 2A. 2 times A is 4. Okay, I try to not write too much so that you have a clearer idea how it looks like. Okay, again, I will have negative 1 here. So I will have negative B plus C. And finally, if I have negative 1 here, I will have negative 5. So 20, I bring over first, equals to 5B minus 5C, and therefore B minus C equals to 4. Divided by 5, divided by 5, divided by 5, I have equation 2. Now what do I do with equation 1 and equation 2? I'll solve simultaneously, right? So solving simultaneously, which I will not show here, because I think the video long enough already. So solving simultaneously, I will have B is 3, C is negative 1. And we are done.